Hello everyone. In the present episode, we are going to demonstrate you the alternating current and direct current using a common source of 220 volt which is there in your home. Now, this is the socket which we call it 220 AC that I will measure with my multimeter, and you will be able to see that the source is 230 volt, 229 something like that. This is 230 volt AC, please note it, and that 220 or 230 whatever we get it. I'm not using directly 230 AC for my experimental purpose. I use another device which is called a transformer step down, and input is 230 and output, if please note, this is 12 or 14, whatever it may be. So let's start from this point that we measured the alternating current obtained from the transformer whose input is 230 and output is 14. So remember one thing, I am having two connections from this point, one here which I will measure again, the same 14 AC. Now for your reference, we are converting this alternating current to so-called direct current using a rectifier here. I must ensure that you are watching this rectifier. This rectifier is having four legs, two input, two output. And please observe carefully, these two red wires are going to the middle terminals and they are all input. That means our AC input 14 volt is entering here and output is DC, and we have given a red wire for positive and a black wire for the negative. That means these two terminals are DC terminals and center terminals are input terminal. That means alternating current will be provided there itself. So for your observation, we will start our demonstration. What we are planning to show, let it be here. And now after the completion of the measurement part, I take over, and now we are ready to show you the impact of the magnetic effect. Let's start from the lamp effect. Now I have got a 12 volt lamp, and this 12 volt lamp will glow here also in AC. That I request you to observe. That lamp is glowing using a source of 12 volt AC. And now again I will test it here because this is DC, I have already told you, and now I will show it that the same lamp is glowing using DC. So what is our target is that we show you the impact of alternating current and direct current using a lamp, and in both the cases lamp is glowing. So from the glow of a lamp we cannot differentiate which one is AC and which one is DC. Now the impact of alternating current and direct current I'm going to show you using a coil setup, inside which there is an iron core, and I'll be keeping it like this, and then I will show you the magnetic effect. That means if I connect using AC, what will be the magnetic effect that I am to show you using a block of iron, and I will place it here, and I will be showing you using this magnetic effect. You will be watching now. This is impact of magnetism using 12 volt AC, and I want to pull it, but this is not sufficient, and there is a humming sound coming out of alternating current. Now please see, I will use now the direct current, and it's more important for all of us that using this direct current you will be watching the impact of the magnetic field using the same coil and the same core. So what effect I'm going to show you is more important now. You can see there is no humming sound, and the magnetic field strength has increased. It is constant because of this constant character of the current. No fluctuation, no variation. The magnetic strength is maintained, which we observe by the pulling of a iron block using our solenoid electromagnet. So using this magnetic effect, I hope we could understand that the magnetic pull is best in DC current, and that is why all electromagnets use DC current, not alternating currents. Now what is the advantage of alternating current? Again, I am ready to show you. This is the advantage I am going to demonstrate. So let us forget the DC effect now. Using the same coil, same core, and another coil and another magnetic core, what I am to do, I will be placing it here, suppose, and then to the down coil I will be providing 12 volt AC, and you will be watching when I keep it here, what will be the result. I will show it to you. Let me connect, and then you will be ready to see that. So this is a connection mechanism we have to follow, because you know we are not having direct switch mechanism to make it on and off. So this is ready. I give the input power, and you should be ready to see the impact here. See, this LED which is supported on this iron is not glowing, but this way I hope you are enjoying. Just I place it and it is glowing. Now suppose the connection is cut, that will not be there. You could check now how this is impacted. It is glowing perfectly, even though there is no physical contact between this coil and that coil which I showed you yesterday, and this is called the behavior of transformer. And this transformer behavior can only be possible using alternating current, but not direct current, that I am going to show you again. So the same coil will be used, but the source will be DC now. So what I am to now, I am to connect first. The red wire is positive and the black wire is negative. So after getting them connected, I will be providing the power and I will be doing the same experiment as I did before. Please be ready. I provide power input. See, this is very fascinating. I will tell you uh, the story of this. This is a pulsating direct current, not perfectly direct current. So this pulsating nature is shown here. Now, the magnetic effect was a very confirmation effect. And now what I want to say, suppose you provide direct current, एकदम perfect direct current from a battery to this coil, and you place it there, it won't glow. We are getting ready to have another session on alternating current and direct current in future, and in that we'll be showing you the details. So for that period we are okay here, and now we need your suggestion for our improvement. Thank you for being with us.